Hey everyone, today we're going to have this LG V10 that came from a customer from Philippines. He saw one of our YouTube videos and he wants his data recovered. I already went ahead and removed the board from the phone. I looked at it in a microscope and it's pretty bad. This phone is in bad shape. I mean, the area here by the CPU is fairly corroded. There's other areas that are really bad. I would love to fix this phone and give it back to the customer, but it's not financially feasible to be repairing phones that we don't have parts for, and I don't think this phone is even available here in Canada, so we would have to order all these parts. But the best thing to do here is to remove the memory chip and read it directly. So I know the customer is after pictures of his kids, so it's very important that we do recover this data, because otherwise he won't have any of these pictures, and this is why we do this. So let's get going with this. We're gonna pop the chip and see if it works. So here we are. We're gonna turn our Rework station on, and I'm gonna adjust the temperature. I like to set it at a low temperature starting point. This is the bottom plate. We're gonna start it up, and it's gonna start heating up the board from the bottom. It's going to make it easier to remove the chip with underfill. So we're going to wait here. There's flux around the chip that I put there. We're going to wait till it starts to melt. The moment I see it starting to melt, this would be a good time to start the top portion of the Rework station, which is the lamp, and we're going to set the temperature pretty low. I'm probably going to start around 150 and then gradually increase it just enough for me to lift this chip. From this point, we have to work rather quickly, because too much heat on the memory chip will actually kill the chip. So I got my flexible blade here, custom made from a razor blade, and what I'm doing here is I'm trying to see how much give I have so far. Like I don't want to bend this chip, because that would also damage it. So I'm slowly increasing the temperature, and I'm trying in the corner when there's underfill, and as soon as that chip gives, I'm just gonna flip it off the board away from the heat as fast as possible. And there it is, the chip is off. So the chip came off pretty clean. Gonna have to clean up all these spots there. There's a lot of underfill. Probably can remove this, it's no problem. The next step will be to decode the chip. Well, read it and then decode it. Here I'm gonna check each individual point or pin on the chip to make sure I didn't rip any pads off while lifting it off the board. It can happen sometimes. One pad might get ripped off from the board. I mean, not every pad is important on these chips, but you know, it's important to have a clean lift. This way you know for sure you can read the chip. So it looks okay so far. So the next step is going to be to put it in this holder, put some flux in, and we're going to start cleaning it. And once again, we're going to use a very abrasive method using solder wick and solder gun. But this is the only way of doing it, because the underfill that's mixed there with the solder, it's very hard to remove. So this process takes quite a long time, and it's very delicate. You can imagine this that braid that I'm using, it's super abrasive, and it can really damage the chip. Just putting too much pressure while cleaning can really destroy the chip and make it unrecoverable. Also, probably applying heat with the solder gun, it's another problem. So we got to do this fairly quickly, and here I am just very lightly rubbing the chip, applying more flux. The more flux the better, because we want to have lubrication. The lubrication is also extremely important. You can see here, slowly that chip is getting better, and the underfill is coming off. I'm just checking here with the solder gun. It's still pretty thick there. The heat definitely helps, but again, it's a very fine line between damaging this chip and cleaning it. So you can see now it's getting a lot better. You can see it's all the dark flux. That's basically flux and underfill together. So there's the chip. I'm just gonna scrape off the sides. This is just underfill that I need to remove, because otherwise I'm gonna have a hard time putting the chip back into the reader. So here's the chip, it's done. The next step is gonna be I'm gonna use the smallest soldering iron we have, and I'm gonna apply new solder, leaded solder, onto each individual pin, because while I was working on it, I noticed that some of the pins looked a little bit I guess dirty, and also using the braid removed a lot of solder. So I want to make sure I have good contact when the chip goes into the reader. So just applying here very lightly, very gently, putting new solder on every single pin. And the last step here is to get some alcohol and Q-tip and just clean all that flux off of this chip so it's not sticky or tacky. So now we're going to drop the chip into the adapter, and that's right there matching the two dots. So now we're just going to plug it into this write protected Cellebrite memory card reader. I mean, it's not necessary, but this is just our procedure and this is how we do things here. And here we are on the desktop. The chip will mount, but none of this data is usable because there's a lot of partitions. Let me just go to computer management, and you can see there's a lot of partitions there. So we're gonna have to image the chip. I'm gonna use FTK Imager this time instead of using Linux. So we're gonna start a new physical copy, select the reader, make it a raw image, put in the case details, and in this case the case number, evidence number, and all the other fun stuff, and where we want to save it. So we're going to put it to our RAID system, give it a name. We also don't want it segmenting, because a lot of times when you're using FTK Imager you can split the image into E01 segments, but we want one single contained binary file. So there it is. It's just dumping the chip right now into a binary image. I think this took about 50 minutes or something. It's a 64 gig chip, so it's a fairly big chip. And just gonna verify it, and there it is. Yeah, we're just gonna check it. Okay, so that's the chip, that's the information. It's not necessary for us for this case, but all we really want is the dump, the actual binary image. So the next step would be to go over to our UFED physical analyzers, start a new case, blank project. We're gonna find the LG V10. We just have to put in the right model of this LG phone. It's a V10. So there's the phone. We're gonna go next, and we have two options: ADB or LIF. We're gonna do ADB. Go next here and select our image, which is saved in the case number folder, and there's the 64 gig image, and we can go finish. So this process will basically decode all the information on it from the memory chip, including the SMS and chats, contacts, pictures, videos, all that stuff. This I think took about 3 hours in total because there was a lot of data on this phone. But once this was done, we were able to recover the data our customer was after, which was contacts, pictures, videos, and a few other things. Anyways, thanks for watching. This is it for this video. Please subscribe for more. We should have in a very near future. Thank you.